Hi, I'm Tom and I talk about code. Welcome to another Rust programming live stream where today, more work on my compiler. Let me just actually show the date on the screen there. We're ultimately trying to work towards strings, but to get there, we've taken a side quest through defining a binary format for my virtual machine. We've done some of these things. We've checked some of these things off. We have a binary format, we can load it, our assembler now outputs to it. We now want our compiler to output to it as well. So that's what we're going to jump in and do. The end of last stream, I started doing that. And I did a bit of work. I did a bit of work off stream. I said I was going to do it, and I did it. I don't always do that, but today I actually did the off-screen bit, which is great. So we made a really important change. We made a really, really important change. We deferred when we actually define functions, right? So, you know, when we see a function, let's ignore inline assembly because this is a bit of a mess. When we see a function, we compile the body of the function. We define a symbol for how many locals it has, and we just keep track of this function. Previously, we were also deciding at this point where all of our functions lived where all of our functions were expected to be in memory. But the problem with doing that is, once you have static data like a string, which could exist inside the definition of a function, another function could push this offset. Let me draw a picture of this real quick, just so we all remember what the kind of ultimate goal we're working towards is. So let's say this is memory, right? And let's say we divide memory up into a few little bits. This is our static data. We'll call this static. And then we'll say this is code, aka text, if you're loading an elf confusingly. Let's call it code. I don't think code is the best name for this, but let's call it code. And maybe have some other sections too, I don't know. Maybe there's other stuff here. You can put anything you want there. I mean, this is the actual memory that is usable, right? So maybe your stack is down here growing up and your heap is up here growing down, something like this, right? The problem is that, and all our functions live in here. So you kind of have function 1 and function 2 and function 3 and function 4, you know, all our different functions take up space in this area. Okay. The problem is that our static data, right, we need to know how big all of the different things we're keeping in here are. And this is going to depend on the contents of these, because we have this kind of bidirectional relationship. A function can increase the size of our static area, right? We could get to this function down here and then realize we need to put something else up here, so this has to grow and get bigger. You know, now it takes up this much space and we have to move our code down to accommodate that. So basically, we need to do both of these things at the same time, and you can't do two things at once. You can't. I'm pretty sure you can't. You can't be in two places at once. So what we do is define all of our functions, then work through all of our functions, work out where we can place them, and then define them. Well, not even define them. Define the symbol with that name, which means that every point in our code that references that function is now, in the final pass of compilation, which happens after this, going to resolve the correct address. Excellent. This is the correct static address. They're always the same address. We're not doing any dynamic relocation here. Nothing like that. Nothing too fancy. Okay, cool. So this is good, and this looks pretty good, and this should work. There's a little problem, and the first little problem is we're not actually building our static section correctly, I don't think. So we need to do something about that. We also need to return something different from this compile function, because currently, well, actually, no, we don't. But we need to change some things in our context, maybe, because we need to be able to get the right things back. So if we have a look at our binary, the binary that actually compiles our program currently, you know, the thing that it writes out, all it does is just dump raw instructions into a big blob, and that's great. And some static data as well first, I guess, right? Get instruction, get static, yeah. So we put static data in there too. We write all our static data, and that's fine. We added this recently because previously we only had global data, which is not initialized at compile time, so we could just dump all of our you know, we didn't need to set this to anything. They didn't need to be in the binary. We just needed to have the right offset when we loaded and executed it. Now we actually need a blob of data that goes somewhere in memory that we can reference. So we need to anticipate what the address of all of our static data is, what the start address is. We need to know what the start address of all of our code is. And these are probably useful things to implement on the context, right? We probably want something like, maybe a function called get code section start, That sounds like a name. That sounds like a real name. This is going to be a U32 because it's an address, an internal machine address. And I really should type def something so I don't type U32. Like I should make a type that represents an address. That's probably a lot better. For now, we're just going to call them U32. So where does the code start? The code starts at, we're just going to return 0 for now. We're not even going to say return. We're just going to say 0. And we're also going to say get static section start. And our globals are going to live in our statics as well, because that is nice and easy. So get static section start, we're also going to return 0. Okay, where do these sections begin? Where do we start putting stuff on top of this? Now, these two things depend on each other, right? One is going to come first, followed by the other. It doesn't matter which order we do that in, but we need to make some decision. So does static data go first, then code, or code first, then static data? I think I'm going to put static data first. I think static data is going to be the thing that goes first. That makes sense. So static data is going to start at 0. It's going to start at 0. Probably going to start at 0, I guess. Maybe we want to make that controllable somehow. Also, all these fields, there's too much public here, but that's something we can clean up later. Code section, however, is going to depend on the size of the static section. Okay? So in other words, we need to sum all of these. Get static. Cool. Here we just build the set of it all. So when we get our static section, this needs to take a ref to self as well. My mistake. I always forget to type this. So for each piece of static data, this is actually tricky, right? Because we have an offset and we have a data. So we know that at offset, there are this many bytes. These could overlap. They shouldn't, but they could. What else could happen? What else is an unexpected quirk of this? Well, what if there are gaps, right? Gaps definitely are valid. So we need to factor in not only how big these things are, but what the gap is. Now, we could say, here's a thought. Let's make a variable called max, and this is going to be the biggest thing we've seen. So if offset is bigger than max, if the offset of this section is bigger than max, or the offset of this section plus the size of the data in that section is bigger than max, which, I mean, this is guaranteed to be bigger than this thing, so really this is just this. So if the extent of this section is bigger than the previous biggest thing we've seen, this is the new biggest thing we've seen. Data.len. Crate L Indigo, welcome. Hope you are enjoying the Rust show. Thank you very much for the follow. Are you a Rust person? Are you a programmer? What brings you to my neck of the internet woods? So this is good, right? This should make sense. Python programmer, exciting, very cool. I feel like I should do more Python. There's a lot of jobs going for Python. They're hanging around. Never used Rust. Well, welcome to a journey. It's cool. I like Rust. I rate it a lot. Okay, so we know the biggest thing we've seen, and that is probably where our static data ends. Also needs to be even. So if max mod 2 is not equal to 0, then we're going to return max plus... Actually, let's do this the other way. Let's return max plus 1 or 0. And actually, I think we can just say max plus max mod 2, right? Because if this is even, we add nothing, and if it's odd, we add 1. This will make it even, right? That makes sense. Rust is cool. Definitely not the easiest language to learn. Absolutely. This is very valid. It has been a journey. I'm still not writing the best Rust, but there's really good tooling to help you get started. Now, what I have just written is not actually what this function's called. What's this function called? Get static section start. What I've done is get static section size. which is also important, because the code section start is probably just the size of the static section, right? I don't necessarily want this to always be true, so I'm gonna call this function, because this is gonna be useful other places as well, I think. Maybe I'll make it like a private function until I really need it. And then we're also gonna make a get static section start, and this actually will return 0, because our static data, it's just gonna start at address 0. That's all we need it to do for now. Cool. Excellent. So, this was good. If I build this, it's gonna yell at me about something, I'm sure. Item list ends here. Oh yeah, I forgot a word. Awesome. Borrow checker and life. Yeah. So yeah, the language, it looks a lot like a C++ like language, but borrow checker and lifetimes, it gets messy. I'm doing a lot of copying to avoid this stuff, but it's if I wanted this to be a really good Rust code base, it would be a lot harder. Write code in different ways. Yeah. Loops and ownership are a bit of a mess. I'm building my own C-like language for my own 16-bit virtual machine, which is fun. Building everything from the ground up. My own binary format, everything. U32 found usize. Can I make this a U32 and then maybe say as U32 here? Just cast our integer types down. This is going to bite me one day, but that's okay. Plus len as U32. Just chuck a couple of as U32s here. Does this need to be bracketed? Like that. Okay, cool. Excellent. So now we have this extra data to work with. We're gonna have to go back into our top level code gen, and when we calculate the offset of a function, we have this program offset variable, which is not quite what we want. We want to get rid of this. Removed some global calculations. Okay, so we've got to come back to this because this stuff is important. We're doing some global stuff. This is all going to get simplified and squashed down into statics, but we need to get there the long way. Tried to make a language in Python and it's a mess. It's hard work. It is hard work. Have you ever built a Lisp before? I think Lisps are a really good place to start. Program offset. Okay, so now we're going to say let mut program offset equal. We're going to get the get code section. And this is good, right? Wrapping this up inside a function. This is what I should have done from the start, but didn't do, and now it's biting me. Lisp. Let me link you a repo in chat. This is one of the best things you will ever do. I recommend everyone do this. It's like the most enlightening thing. Also, structure and interpretation of computer programs is a cool book. Cool. But yeah, C-like links have a lot of weird quirks. I had a lot of fun with left-hand side versus right-hand side pointer derefs because it turns out they behave very differently. Sigonull, welcome. How's it going? How are you doing? Bobius, thank you for the SICP link. I mention this like every 3 or 4 streams. I should just probably have it permanently in my video descriptions, but I don't want to use Nightbot. I want to build my own Twitch bot, but maybe I need like an exclamation mark SICP just for that link, because it comes up so often. It's a really good book. I've actually never done all of it. Yeah, should have a command. Would people be interested in watching me build a bot that did this? Would that be fun, or would that be tedious? Because I don't know, I kind of like running my own stuff like that. I've got a Raspberry Pi that would do it. Anyway, sorry, I'm getting sidetracked. So we're working out the offset now. This is okay, except when we do globals. So let's go into our block compiler and find where we have stuff like special cases for globals. Block codegen block here, global. Okay, so we compile the expression adder. Where does adder come from? It's already baked in. It's already baked in. Already baked in. So where does this come from, right? Because this is an address. Where do we... It's hard when you start forgetting where you did things. Where have I referenced global? I want this without the case insensitive. So AST name type. Yeah, so... Oh yeah, it's in top level. What am I saying? It's a reference there, but when we actually do the assignment, it's in here, global variable. Okay, and so we push into the global map. Right, we have a big list of globals, which is good. The global map, at the name we put the type. That's all we do. That's a name and a type, because that's all a global variable is at this point. When we're at this top level, we're just forward declaring that a global type exists. Now the good thing is, static initialization is going to get easier now that we have more interesting stuff going on in our binary format. So global page size, blah 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 blah. I don't think I want to use global page size anywhere. I also think I want to get rid of this, program start offset. I don't think I want to have a field called program start offset anymore, because I have a function that calculates it instead. Program start offset. Yeah, so I want to streamline this a little. Bobby is thinking of switching to Zig for his parser combinator because Odin isn't working out. Yeah, some of your Odin generic problems look very complicated and messy. I can't reason about them. I don't have the Odin experience. But Zig is cool. I should do a Zig stream. I think a Zig stream would be a lot of fun. Like make a little game or something, compile to WASM. Zig compiles to WASM pretty well, I think. Okay, so global... Cool. So we have a map of all globals, and we define them in our context. A string and a type. Global head. Now, we probably don't want this extra variable called global head because it's all just... Oh no, we do want this variable global head because that's what we're using for all static data. So global head, we actually probably want to just rename to... And let's do it. Let's do a big rename. Global... global head, and we'll call it static head instead. And it's going to yell at me about some stuff. Program offset not found. That's okay. Now, why does compile body need a program offset? This makes me nervous, right? Because compile body should not use an offset. Zig, null, Zig's fun to work in. What have you done with Zig? What projects have you bitten off? Why does compile body need an offset? Where is this offset used? Block takes an offset in its construct. Huh? This variable, this is a shadowed variable. So offset is only used when we actually create the block. But it really shouldn't need an offset. Register labels. We don't use, so we should see like self.offset, and we don't see it. So I'm gonna delete a field. What's the worst thing that can happen if I delete a field? Program offset not found in the scope. Yeah, that's because I got rid of it. It's gone, mate. Offset is program offset. Okay, well, let's just not keep track of this anymore, right? Like, it feels like we don't actually need to track... The offset doesn't need to be part of the state of the block, right? What's the worst thing that's going to happen? Oh yeah, this block.offset. That's okay. So we just use program offset instead, right? It was a bit of a smell. This should have been a smell that I was assigning this thing, and then the only place it was really being used was right after. Also, we got the name of the function somehow. I made my list of functions, right? Like instead of just being a block, it also has a name associated with it, which is important because we need to know this name when we define the symbol. Infinite coder welcome. That's a fantastic emote. You're really showing me up on my emote game here. That is really sick. That is really sick. Okay, global page size unused. Feels like we can just get rid of it then. Let's do it. Program start offset unknown. That's fine. That's fine. Context program start offset. Let's say program section start at, and now this will be get code section start, I think. Something like that. And then they're here as well. And this is when we're actually generating our offset, and so this is fine. We'll just say, this, is not how we're going to do it anymore, but we'll just get this consistently working with the old state of the world for now. Get code start offset. No, sorry, it's called get code section start. Wrong name. And it has to be as sure. I don't know if it does need to be as an F32. Oh, because I want it to. No, that's fine. Can I not just divide by 2? That's really silly. I don't know why what was I doing there? Cool. So what happens if I compile something now? That looks about right. We have an offset of 12, which is a big number, but that's one global. That's 2 bytes for a global, 2 bytes for the length of a string. So 4 plus 7. That's too many. Oh no, that's right. That'll take us to 11. So we want the offset to be 12. So that should actually be correct. What if I don't do this? Don't do it like that. Label out. Okay, so if we interesting. So what happens here is we have this check. We say what format are we outputting this in, right? Is this annotated assembly or is it a binary? And for some reason annotated assembly doesn't fail, but when we try and actually resolve this into code, it blows up. So what is going on? What's different between the two? Well, what's different is we actually resolve all of our instructions, right? In this format, all of our symbols remain. Well, no, they don't. Yeah, because we define them up front. Weird. Loop out. Foo main. Cool. Print main. I mean, we don't actually need to define foo and main ahead of time. We can actually work those out as well. So what isn't it finding? It's not finding while label out. While label out. So is it possible that we're no longer defining these symbols? Okay, so why is this error just giving me this? Why isn't it giving me more? Right, these errors were a lot more verbose before. Trying out Zig. Zig has rough edges, range only use size, type inference in Zig. Yeah, I don't know anything about that, but comp time is really good. Comp time is amazing. This is probably the killer feature about Zig to me. Building's good. These new languages have really good tooling. Add packages to a Zon file. Not quite sure what you mean by this either, but yeah, it would be fun to play with Zig. C3 generics are weak. Just use any and runtime type check stuff. The Golang approach, which is fine. You know, Go does actually get quite far just by making you use any and then, you know, do runtime assertions. It's okay. It's It's not the end of the world. It's not a good system. It's not as good as what Rust has, but you can write perfectly good code like that. And Carbon, yeah, I don't know. I don't have a lot of faith in Carbon, to be honest. Jai seems interesting, still private. How they do compiled any. I mean, it's just like any other data, right? You probably just have some kind of tag that goes with it, because if you can reflect on it at runtime, yeah, pointer plus type ID, exactly. It comes with some extra reflection info in the data. And you can do that in C as well, right? If you allocate something, you can do this with strings. If you want to allocate a string of length 10, you can allocate a string with length 10 plus, size t, and then put a length address like just before the string, and then return the address plus 4 or whatever. Yeah, so calling any.sum function, right? You can't. What the code that would be generated would be look at the runtime information, right? Look at the type ID and then resolve it at runtime. So it would be more expensive. But this is how languages, this is how JavaScript does a method call, right? Every method, you have to look up what the type of the object you're calling that method is, and then work out how you're going to dispatch it. It's not a string name. It'll be like a hash or something, right? There'll be some smarter way. But even in JavaScript, this is they use a hash. It's not an interrupted language, no, but if you're calling a method on an untyped object, you have to do the lookup at runtime. There's no other way. You got to look it up. So either you're asserting that the type is so either you're saying hey, I'm asserting that this matches some object, right? I'm casting it some smarter way. But that's what it is, right? You either at compile time you assert, I'm writing the code, I assert that this any is of this type and I'm calling a method, then it generates code to check the type ID and blow up at runtime if it can't do that conversion, and then does the normal vtable lookup. Or it's just fully, maybe the symbol gets renamed in the runtime. I don't know how that necessarily helps the lookup though, right? It's I don't think it's complicated. I don't think it's particularly smart. I think the stupid thing works surprisingly well for that kind of dispatch. I also don't know how typed it is and what the semantics of any.sum function are. Because if you take Go for example, if you want an any, this is turning into a bit of a podcast, but if you want any.foo, x.foo in Go, you have to assert that x is an interface to begin with. But what is an interface if not just a certain guarantee? Just because you have an interface, a type fits an interface, doesn't mean you know how to look up where those methods are exactly. You have to do some runtime stuff. That's what vtables are all about, basically, right? You pass some information along with the object. Cool. Okay. Why is this symbol not known? What has happened to my symbol? Why can't we resolve it? What extra step is there between these two things? So we look at all our symbols, look at all our stuff, where is it? Compile the program. Here we get instructions. Get instructions resolves. Here we don't call get instructions. Right, here we do, and get instructions does all of this resolution. So what I suspect, because we're referencing this thing before it's used, right, reference before use, we need to make sure we're still defining our labels. So if we look at block, register labels. Let's search for that. Yeah, cool. That makes sense. We're no longer registering our labels. Why not? Because registering labels, when we register where in memory our labels exist, we need to know the offset of the function in memory. We rewrote my top-level compiler to defer function placement to the very end, and since doing that, I forgot to tell the block to register labels again. So we can just say register labels. This won't work. It won't work because I'm going to say context here, and because we've already mutually borrowed context for this loop, it's going to yell at me. So we're going to get to see a borrow checker error, but I'm going to do this just to start with. This is program offset. Okay, so when I build this, the borrow checker yells at me for a couple of reasons. We need to mutably borrow. And now it's going to say you can't mutably borrow while already mutably borrowed, which is cool. I mean, building encoding phase. Yeah, you can switch to vtables. Yeah. Are we building my own compiler? Rebooting after full system update. Good luck. Thoughts and prayers. Yeah, this is my own custom language. It just looks a lot like C. But everything, I've invented everything here. Built it from the ground up. Except for the Rust programming language that I'm writing it in, of course. I haven't done a full bootstrap. Not yet. That's next. The full bootstrap, building this compiler in itself, that's the next step. So, how do we break this mutable borrow loop, right? We can't mutably borrow context while we're inside this loop. And do you know what's really funny? Do you know what's really, really funny? I just got rid of... oh no, it still won't work, will it? I just got rid of storing the offset in the block. And that actually might be the thing we need to break the loop. I guess the other thing we could do... It's hard to think about what this will look like without this loop. I'm going to put the offset back in the block. You're coming back. The offset's coming back, okay? So what we're going to do... We're going to say block.offset equals program offset. And then we will do this in a later loop. We'll say for block in functions. So for each function, register it in the context. Now, the fact that we're looping over context functions probably means that this will still break, but this is a better place because we don't have a nested mutable borrow. It's going to be better. Yeah. Okay. Partially moved. And the values used after a partial move. I forgot. If we weren't doing this, this would be a lot easier. El Kasi Hacker, welcome. Thank you very much for the follow. Sorry. I didn't realize that was we had someone follow recently called Crate El Indigo, and I merged you together in my brain with them because you both have L in your name. So, sorry. Thank you very much for the follow, though. Hope you're enjoying some Rust. And that was a very quick reboot after a full system update. Are you running Windows? That's unheard of. So this won't work. This doesn't work because we're borrowing mutably inside of an immutable borrow. So we got to think. We got to use our brain. One thing we could do, right? One thing we could do is copy this whole array because it's actually not that big and complicated. Oh, it has all the instructions as well. Has all the instructions as well, because it has to. So, I mean, look, I can do this. I can just clone this whole array and loop over it like this. That will work. It's really silly, but it will work. That breaks this dependency, this cross-dependency. Okay? Actually, what's interesting as well is I don't think this needs to be mutable anymore if I don't put the offset there. So maybe, just to simplify this, what I actually do is... That's a really weird simplification. I didn't realize this. I didn't realize I could do this. But maybe I can actually work this way, make a clone of everything, loop over it. Okay, that's kind of good. That's kind of good. NixOS. I should have known. That was quick. That was snappy. You didn't NixOS rebuild. Yeah. No, that's cool. That's cool. I need to try NixOS. One of my friends has recently installed NixOS, I think on one of his laptops, and he says it's good. He's rebuilding his whole server around it, moving from Arch, and he's tempting me, right? Every time I talk to him about it, it sounds good. I do like the sound of GUIX as well, though. Okay, so our globals and our statics should now be playing nice, and we shouldn't see this error anymore. Awesome. So this is a binary, right? This is the entire blob that our machine would know how to run. Let's pipe it into XXD and see what it looks like. Cool. So this is a global. This is where we reference a global. This is where our string lives. So this is the length, and then 1, 2, 3, 4, 5, 6, 7, and then a padding byte, which is perfect. Then this is where our code starts, and everything from there is the code of our program. So this is a binary. This is this isn't a binary. This is a form of binary. This isn't using my new binary format. It would be nice if we had a bit of metadata along with this saying, hey, here's our static data, and then here's where the code starts, here's where you load them into memory, here's the entry point. It would make my life a bit easier. GUIX doesn't support proprietary hardware. Gentoo's hard to start with. Nix is annoying sometimes. I imagine Nix could be annoying. But I think I would take annoying for being able to like define my own script for managing my system. Also, welcome, Dan Dida 995. It's a good name to say. It's a fun name to say. Contemplated checking Nixos. These days you're lazy. Will this use glibc? There's no glibc on my 16-bit virtual machine that this is targeting, so no. I mean, the compiler uses glibc. Gentoo was much harder to start with in 2006. Yeah, the docs have come a long way. They've come a long way. Linux with no... I mean, like, the host system uses glibc, but the target computer, there's nothing. There's no software. It's just the barest bones system possible. Let's try running something. Let's try building something. So let me... I don't actually have a good way to load a binary blob directly. What I really want to do is to load a base 64 string of this. That would be good. But I don't support that. I don't support that. What is my distro? My distro, I'm running Arch. It's very simple Arch, Zen kernel. No, this is a fake window. This is DWM. Surprise. It's the DWM taskbar hiding out there. I just hide it and make it's a vaguely Mac-like. Like, the UI at the top of this fake window, this whole window is just my entire desktop. I just wrapped it in a thing that makes it look like a window. It's all a trick. Boots to metal. Yeah, so the machine, like, it's a little virtual machine that I wrote. So there's no kernel, there's no operating system. I'm running binaries directly on the metal of my virtual machine. Ubuntu compatibility, yeah. Yeah, it's a good scam, isn't it? People really fall for this. It's good fun. Awesome. So I used to have a way... Actually, you know what? I'm going to hack this back in. I don't think it's that bad. Let's just go to my page. And... oh god, this is a real rat's nest. I'm rewriting this entire front end with Vue.js, so I don't have as much document.getElement by ID. I rely on that to power everything here. When I set up my virtual machine, program start, init VM. So, what I'll do, okay, so when the page loads, right? When the page loads, build, so when we click build, program start. So when we, okay, so we're gonna do this, init VM set halt true. We're gonna, if, what I want is to be able to say bin equals this, some base 64 string, and if that's present, we're just gonna build and run that straight away. We're not gonna show the editor at all. Could have gone with jQuery, but that's still using getElement by ID. It's just a little bit more compact. I am not anti-jQuery, but reactivity was cool as well. Building it to be reactive, like, I mean, I can show you later in the stream. jQuery is awesome. I learnt with jQuery. I definitely am a jQuery appreciator. But I don't know, having it reactive is fun, because I can just say, like, vm.a for the A register, and then every time the VM updates, it propagates through. How do I do query strings? JavaScript... I can never remember. This is one of these things. I Google 100% of the time I do it, because I only do it every 6 months. Sure, let's copy and paste. My favorite thing to do from Stack Overflow. This is right. This is right. I'm thinking of making a clickbait video, by the way. I'm thinking of making a clickbait video called "Why I Don't Use Code Completion," because I get asked about it a lot, and I think that could do well in the algorithm. But yeah, that would be. I don't know. I thought that would be fun. Hopefully, it's not too scummy. So preload bin. We'll call this preload bin, and then we'll say if preload bin, then we'll init VM we need to decode this base64 as well, dump it into memory, all this stuff, all this good stuff, all this good stuff. VM registers, update code view. We're not good. I guess we'll say update code view as well. ASM and upload. Update code view. So we don't do that. We don't do that. We just dump it in write program. Base64 decode. Didn't say it. No elf headers. Yeah. So this is literally, I've invented my own instruction set architecture. I've written the virtual machine. I'm making my own binary format. This is everything from the ground up. Reactive stuff is heavyweight. Yeah, I'm accepting that just so that I can say I've done it like the normal way. Because there's a lot of front end stuff, and I would like to show that I have some full stack experience. I may as well use what's kind of in vogue. IntelliSense sucks most of the time. Yeah. I find it invasive, right? It's cool, but I don't know. I like it. I like how clean it is. Now, there's a simple way to do this. To uint8 array. This is what I really want. I want it array buffer, I guess. That's fine. Yeah, here we go. Again, another thing that I Google and copy and paste every time I do it, because I just can't. I just can never hold this in my brain. Thank you, Stack Overflow. Oops. Cool. This, yeah, so this is a rat's nest, right? This is getting really, really ugly, but that's okay. Bytes. We're not going to return the array buffer. We're just going to return the whole uint8 array. That is okay. Let's say to array buffer. Awesome. VM program offset. Now this offset we're gonna hard code, I guess, because that's silly. To 12, to 6. I think 6, maybe 6 or 12. I can't remember if I need to double it here or not. I think I do. I think 12. Cool. And what else do we say? vm.set halt true. Let's see if this works. Let's see if this works. It looks like it did, which is funny. It looks like it compiled this, which isn't right. So that did something. It did something. And it VM does all this stuff, binds the handlers, except these, yeah, for IO. Window next to you with documentation. Yeah, definitely. This is one of my favorite things about Rust, actually, right? And if you're not a Rust person, this is going to blow your mind. Rust up doc. You get the docs for your exact toolchain version, and you can pull them up and you can search them really easily. Actually life-changing. Actually life-changing. That's good, it's good. Tab completion has its place. I like the NeoVim way where you can have tab completion bound to a key, so you can start typing and then press a key to bring it up if you want, but otherwise ignore it. I think that's probably the sweet spot, and that's probably what I will do when I go back to working on projects bigger than my own hobby projects that just happen to be like, you know, however many lines of file, however many lines of code. It's not that many. Rust. Why is there? What the hell? Why is there D in here? This must be a dependency or something. You know, I've got like 7,000 lines of Rust code. I guess I actually just want to look in these two directories. 7,000 lines of... Why is there D? What's... You can press the key to bring up completion simulator. Yeah, okay. So there's a way to set it up. NeoVims I found particularly nice. I never got it working the way I wanted it in Goland. Why is this jumping me straight in here? Why is this jumping me straight in here? Why has it compiled the wrong... Why does it have anything here to begin with, right? Oh, because it does this as part of... Yeah, that makes sense. That makes sense. Init VM does this assemble and upload. How often do I call init VM? Only once. Okay, so we're gonna move this out of here. We're gonna say to target, blah blah blah. We're gonna say actually let's yeah, literally just move this outside. Let's do this. That works. Okay, perfect. Cool. Now for some reason this doesn't initialize the program counter to what I said it should. So that's not good. That's not so good. I think the thing is, in every other IDE, my hands aren't on the keyboard, so control space, or like, I don't know, I'm just going back and forwards, whereas having it all, like when you're in a keyboard workflow, a keyboard shortcut to bring that up makes more sense to my brain. I think that's what it is. But control space is pretty easy to press. But you do have to like move, like rotate your hand around, right? I can't reach control and space comfortably while my hands are in like the native home row position. But yeah, you could configure it. You could configure it. God, this is really silly. This is really not my best. What I want is actually to disassemble the code and show it here, like update code view, code lines. But code lines, I could, okay. Let's disassemble. Let's write a disassemble function. I'm hacking this on because I want it to work. And I'm literally going to throw this all away for the new front end I'm building, but I don't know, I guess it informs. Disassemble, I think double is right. So, and we'll say PC offset, maybe. So, let I equal 0, I less than, or let I equal offset, I less than prog. So for everything in prog bytes, for some reason my syntax highlighting breaks if I write a lot of JavaScript inside a HTML file. I have to like scroll back down to it manually. If I try and jump around too much, it'll break. Cool. Disassemble 1s then 2. Thank you. I need spelling help. That looks right. Once you get it right, you know, but until then it looks wrong. So we'll say b0 is prog bytes 0. I think there's a smarter way to loop over this as a 16-bit array, but we'll just do the combination ourselves. The instruction is going to be b0 or b1 right shift 8, both little bytes. Then we need to disassemble, which is actually in WASM ASM, disassemble instruction, which I spelled incorrectly, thankfully. And this returns, yep, cool. So we'll say out is just an array. We'll say out.push name, and then we return out. Done. Don't know why my indentation was weird there. Awesome. Bobius, your spelling's decent. There are a few words. What are your words you can't get right? I'm trying to think. There are definitely a few for me that catch me out. What's going on with this indentation? I don't even know, man. This file is a mess. This 400-line file is a mess, unsurprisingly. So what happens if I run this now? What is this? Well, I didn't do anything, so of course that's what it looks like. So we wrote a function called disassemble, then we need to say update code view, and we can do that as well. So let's put a mark on disassemble. We'll jump up to where we're calling init VM here. Let's say const lines equals disassemble program bytes, and the offset, which we're hard coding at 12. And then we just want to say whatever this, oh, I just deleted my mark, that's annoying. update code view with the lines, an empty set of symbols, and our offset. Beautiful. Okay, now this should look better. Line is not defined because it's called lines. Sims is not iterable. This needs to be a list, not a map. Nice. Oh, look at this. This is delightful. Delightful. Why are they all invalid? I don't know. I have no idea. Why is this an empty object? I also don't know. Okay. What's going on here? What's going on here? Disassemble. What are you doing? Let's just put mark Z here. Oops. 0 goes to invalid. I equals offset. Yep, that makes sense. I don't know. Sometimes you just have to make a kooky error to get there. Turns out always accessing index 0, which is not code, is invalid. Now, does this look like the binary we want? No, this doesn't make any sense. This is nonsense. Store byte, 0b, store word. Shift left, 0, 0. Like this actually makes no sense at all. No, it is actually nonsense. It is actually nonsense. That's weird. that's strange. Let's go back to looking at what this data is, right? And where our code starts. Our code starts here. And this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what if we start at say 16? What if we say start at 17, right? Because it looks like we're interpreting garbage data as code. And honestly, like maybe we are, because this looks like too many instructions as well. I feel like we shouldn't have hex 504. No, 5. I feel like we shouldn't have 504 instructions. This is decimal. This is decimal. Why are there 504? So, actually, hold on. What am I trying to do here? So there are 100 hex 1 0 1 0 1 2 3 4 5. So hex 06. Hex 106. 262 bytes worth of instructions. So that should be, it should be about 120 instructions, not 500. So something's gone wrong here. Maybe with our decode. What happens if I reset the machine and try and step through this? We reset the PC to 0, which isn't right either. We use this VM program offset, which, let's say VM program offset is 12. This is a horrible bit of state, but that's okay. So we're hard coding this, but we're gonna change it to load. We're gonna change this to load this offset from the binary once we parse it properly. That's better. Okay, that's different. That's different. Now, again, the PC still isn't getting reset, but that's okay. Yes, you're right. I'm not adding 2. And actually, that's a really good... you're spot on. I don't know why I'm struggling with loops so much lately. You are absolutely right. This should be plus equals 2. Yeah, so I was looking at 0, 1, 1, 2, 2, 3. That's really silly. Let's also give it a I, just so I can see what we're doing. 0, 2, 6, 8, blah, 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 blah. Let's maybe also do offset plus I, so we can see what this should correspond to in the actual file, and maybe as a hex. Oh, I can't do a format specifier like that, can I? That's okay. 0, 0. Not right, but closer. We're still starting at the wrong spot. This is actually garbage nonsense. But yeah, thank you. This is why you need backseat drivers. This is why you need people. Like, I'm saying words. I need people to actually be paying attention to the code. Huh. 0, 1. Little endian. That should be fine. It looks okay. Disassemble. So we're doing the right kind of thing. We're just not pumping the right data into it. Now this offset isn't correct. Okay, this offset, VM program offset. Why do we reset to the wrong address? Why does this not get set? Do I need to, is my cache on? Do I need to do a harder reset? No. VM program offset, and if, hold on. I need to set this after we call init VM. I need to override it. There we go. Okay, well that's good. Instruction invalid. Because I suspect this isn't being loaded into the right place. Program bytes in program offset, update code view. It actually does something, which is weird. It's reading and writing some data, and then it cries at me. Highlight line. Weird. Okay, we're honing in though. We're honing in. Right, so what should the first instruction be? That's also worth looking at. Oops. God, I hate that shortcut. The first, so it should be, yeah, like you'd expect, load an immediate, shift left, stack, blah, 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 blah. So what do we get instead? We get a store byte. Hold on, have I byte swapped them? Let me just try this. Let me just see if I've byte swapped. No, that's still not right. Weirdly enough, it's still not right in a kind of confusing way. Also, we don't want to add I to the offset. That doesn't make any sense. If anything, we want to subtract offset from I, but that's still not. It's also still too many instructions. That's the other weird thing. So, do we actually decode this correctly, right? Has my random blob of Stack Overflow code not correctly decoded this base64 text? Preload bin, program bytes. It feels like it should, right? That feels correct. Bytes, unit binary string dot length for each thing, cal code at. Yeah, that's good. And I probably could also just use car code at and read it out directly, but I would rather not do that. Oh. This feels right. I don't know what's happened. Why are these such kooky instructions? Let me try a different offset let's try an offset further into the program. Okay, so. 138 lines here of code and labels. So this should be like 1, 2, 3, 4, 5, 6, 7, 8, 9. This should be 100 what did I say? 138. So 125-ish. And instead we get 258. So it feels like, actually, I'm gonna go out on a limb and say that we expect 129 instructions. I'm gonna go out on a limb and say that we've doubled. Up somehow. That feels reasonable. So, I less than that, I plus equals 2. That feels good. Why do we have anything? Most of these are less than 2 bytes, which is weird because the opcode, right, our instruction format, we would expect lots of things to go in X and Y. We would expect, in the upper bit? Immediate 1. Okay. So this should be the upper bit, right? This should be the second 8 bits. The upper byte, sorry, the second 8 bits. And we would expect things to go here, right? We expect lots of things to go here. We expect far more things to go here than we see, where all of these except for 2 are less than 256. Which is, that's strange. So that tells me that we're reading this data out wrong, right? We're reading this data out wrong somehow. B0, B1 left shift 8. That's fine in JavaScript. We don't have to worry about any of the stuff getting truncated or anything like that. Weird problem. We increment by 2. We start at the offset. We increment I by 2. And we read, unless there's garbage at the end of the string, right? So let's maybe, can I print an entire uint8 array? Let's go down to disassemble. Let's just print out all the bytes. Let's have a look at them. Okay, so again, it has a length of 259, which is what you would expect if we wanted half of that length. Yeah? 007, 0. So again, if I look at the output of this in XXD, 0070, I'm guessing this is 666F because these are only, you know, what is it? F, 6 to F. I don't know. This feels like the correct distance. So this looks like the right data. We started offset 12. 2552. So straight away we can see that the first thing we see, the offset 20, 1620. So straight away this is wrong, right? Straight away this is only considering this first byte. So this is kind of what I was saying. It's not looking at the upper byte at all. So I've done something really silly here. Done something really, really silly here. Logical OR is correct. I know, not code 16. Okay. Oh. Do you see what I did? Do you see what I did? Do you see what happened? I see it now. I was saying logical OR, not bit OR. That's really silly. Okay, so now there's something going on. Unknown opcode. So now we have an unknown opcode, because yeah, that's good. So let's just say -1, because that works for this data for now. Maybe? No? 138. Unknown opcode 16. So it looks like we have a stray number at the end. Maybe? No. I less than 138. 138. So at 138, we have something that's not a real instruction. 138, 12 and 3. Is that what we get up to? No, 13. So it should be 140. Unknown opcode 16. Yeah, I don't know how that took me so long to spot. That was a real nightmare. That's literally in front of hundreds of people are gonna see this. It can go on my permanent record. That's good. I'm happy for people to see a real programmer hit a really dumb issue. Right? Yeah, I don't have this defense of it being 3 AM, but you know, like, it doesn't matter how good you get at coding. Sometimes you make the stupidest little mistake and just bash your head against it. Cargo Clippy would have warned me about that. Probably. Or, well, if I was doing that in the Rust side, right? Like, this is somewhere where the right tooling can give you a warning. There's probably a linter that would have picked that up somewhere. I don't know if the default JavaScript one would if I haven't had it set up, but you know, that like having tools to help you out with that is definitely good. But yeah, sometimes you just make a really dumb mistake and get stuck there. Okay, so let's do a really silly thing, right? Let's try catch it because I'm not sure what's going on. And we'll just console error something silly. I will say E. That's all we're gonna do. And we'll just power on through. Okay, so we've got a couple of unknown opcodes. Otherwise, this is okay, except we've got a couple of holes in our program. VM Pro. Okay, so now we've got the right looking code, but we're missing a couple of things. Opcode, unknown opcode. So I'm guessing this is actually part of my macros unknown opcode. Yeah, this is deep in the weeds. So why do we have an invalid opcode here? Strange. Oh, actually, I know what this is. I think I know what this is. Maybe this is the instruction refactor I did. Maybe I haven't rebuilt WASM. This is always worth checking. So just make sure your WASM binary is up to date. Okay, that's not the case, but that's good. That's good. Let's also print out the how do we do this? JavaScript format string as hex. We gotta. This is also one of those things. String 16. So we're gonna have ins.toString16. Right. Again, one of those things I have to look at every time. Yeah. Instead of bar, that I do end instead of or all the time. I don't know why. It's a real brain issue, but it does really happen. Okay, so 1364. Now I also want I want a left pad. If only there was some useful JavaScript dependency that would let me left pad a string. If only there was some helpful package. Pad start. That's right. There's a method for it now. I want pad start to 0. Okay, here we go. Here we go. That didn't help. What the hell? ToString16. Hello? 3, 1. That's not a. Oh no, sorry, it's the errors. It's the errors. There we go. That's still not right though. I still don't have a 0 pad because I want 4. That makes sense. There we go. It's always the silly mistakes. It's always the dumb little mistakes. 1364 031. So what instructions are these trying to even be? So this is after EXOR. Wait, why do we have an EXOR in here? Whoa, 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 whoa. Something funky is happening. Have I... So, okay, let me bring this over here and go side by side with this. And then we can see, so let me see if I can I not zoom in? I apparently can't zoom in on this. I'm sorry if this is small, but here we are. So MSP, SP4, blah, 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 C0, SP2. So let's look for a sequence that is kind of distinct. Do we have a set and save? I don't think we omit a set and save. So something does go wrong somewhere along the way here. Phila, welcome. Thank you very much for the follow. This is we're going, we're pushing on. Okay, so something breaks apart somewhere, and I think it's around. I think this looks okay. Either non-zero. This looks okay. Something's vibrating in here. I think someone's playing music outside. That was weird. MPC. So this is all good. Load words, stack, add. Here, this is where we go wrong. Something goes wrong. Oh, we get an invalid as well. I didn't even notice that. So up until here, we're fine. And then it's like, we just jump off the freaking deep end and everything falls apart. That's strange. That's really strange. Let me recompile this to base 64. let me re-base 64 this. What am I? Let me re-base 64 encode this, and let me... Can I put stuff in quotes? Yeah, but that's not helpful for some reason. Is this a URL encoding issue? No, but base 64 is immune to that, right? Is it? Maybe? I don't know. That's weird. That's weird. Why does it get partway through and then just like shit the bed? Like, yeah, these aren't correct. So what's the offset? Let's check the actual bits and make sure the bits are correct. So it's after, where is it? Ether non-zero, PC for MC, load word. So it's right here, right? It's right in here. So ether non-zero, ether non-zero, ether non-zero, PC2, immediate, C0, load word C0, stack push, here, right here, A. And then it just like falls apart. Does it get back anywhere? Does it ever come back? No, because we get this EXOR. Nothing emits an EXOR yet. No code emits this. It shouldn't even be in here. Multiply CCB. Do we see this somewhere? No. Set and save. No code emits this. No code emits some of these instructions. I don't know what's going on. So it happens at, where are we? Address at 84. At offset 84 here. So 84, we have 9254. 9254. I'm going to need to convert these into hex. So we're looking for 5C36. Cool. Let's put you back over here. 53C6. Let's grab this into XXD. 192. Thank you. CO36, which looks like this. So I see a bit of CO36. I see it. It's in here quite a few times actually. CO36, because we're little ends over here. Little ends over here. CO36. Okay. So what instruction do I say this is? 84. Load word CC0, whereas this code says that it should be a load word CC. Oh no, that's right. Hold on. Sorry, it's 88. It's 88 that's wrong. We have a few of these. So add the base pointer to 0 and store the result in C. We're saying store the result in A, which is subtly different. 88. So instruction offset 88. 1628. We can do this too. Hex 16. This is just 10. And then 28 is probably, hold on, can I do this in my head? It's 16 plus 6. It should be 16, right? Or 1C. Oh yeah, I hold on. Numbers are hard. 1628. 1628. So let's check here. And we expect it to be somewhere, I mean, I can probably 1628. No. 1628. No. So maybe it's not even in here at all, right? 128. No instructions ending in 28. What about 16? Okay, that's interesting. That's interesting. So what should it be encoded as? What should it be encoded as? This is offset in the file 88. So we can actually do that here too if we convert to hex. Hex 88, that's 58. So 5, 0, 1, 2, 3, 4, 5, 6, 7, 8. Here. Now here's the CO36 that we were talking about before. That's good. So 103E. So that's close, right? 103E instead of 1C. 3E and hex 1C. So how many bits are different here? We're going to have to draw this. 0x 1C, 0x3E. How many bits? Okay, but fundamentally, we're just seeing different data here, right? At base 64, decode has blown up. Something has gone wrong because this is not what is actually in the output at this point, which is a really frustrating kind of thing to try and solve. Like, what do you even do about this? How do you even deal with this? Oh dear. Okay. What do you even do about this? So how many bits are different? How many bits are different? C to E. So C is, so this is 0, 0, 0, 1, 1, 0, this, so what have we got? 8, 9, A, B, 1, 1, 0, 0, C, D, E, F. Yeah. And this is 0, 0, 1, 0, 1, 1, 1, 0. So this is 2 bits different. 0, 1, 1, sorry, 1, 1. 2 bits different, right? So this bit and this bit are different between these two. So where have these 2 bits come from? And I assume that after this point, all of our data is going to be wrong. Let's check the next one. 1, 2, 4, 8. 1, 2, 4, 8. So this is C. Is it? D, E. Yeah, C, 4, 8. So 4, 8. 3, oh yeah, of course. That's a nice round multiple of 16. 1, 2, OC 3, O. OC 3, O. What do we see after this? 1, O, 3, E. 7, O, 3, O. What did I say? 0C 3, O. So it's different, right? 7, O to 0, 3, that's even more different because like 7 and C, they're quite different. 0x7, O, 0x0C. I mean, this is many. This is 0, 1, 1, 1. 0, 0, 0, 0. This is 0, 0, 0, 0, 1, 1, 0, 0. Like we've got 1, 2, 3. Like we have no bits in common. No. Sorry, we only have 3 bits in common. Sorry. So the only bits in common are these 3. There's 5 bits in the middle that have changed. So that's not good. That's not a good thing to deal with. This is a C. This looks a little bit weird, but it's a C. So why has this happened? What's going on? Base 64 shouldn't be lossy. Okay. Is this can I wrap this in quotes or something to make sure it's like decoding it correctly? Another thing I might try just out of desperation, right, is when I grab the URL params, I might just console.log the preload, the actual binary string, right? Let's see what we've got. What are we working with here? Okay, can I copy and paste this back in? There's a couple of spaces in it. So what happens if I echo to base 64D? What am I doing? Okay, let's pipe this to A. Let's pipe this to B. Diff AB? Yeah, there's diffs, right? Right at the point where the binary goes off the fucking chain. So, the Bobius has sent me a link. Converting arbitrary binary data. Interesting. This looks way more complicated, but that's okay. Bytes 2. Data URL 2 bytes. Okay. That is interesting, actually. I think I like this better. Let's do this. I'm not sure about oh no, can I await? I don't know if I can await inside here because this isn't can I just make this an async callback, an async function? Maybe. I don't know. We'll find out in a sec. So preload bin. So instead of this, let's just paste this function in. And copying and pasting from MDN, this is a higher tier copy and paste than from Stack. This is our scummy Stack Overflow copy paste. This is the Chad MDN copy paste. Okay, so instead of this, we're gonna call let's call this data. We'll call this data 2 bytes. We'll build our URL, data URL. It's gonna be this, and then I think we have the comma, and then we say plus data, right? We just cat it on the end. And then we fetch the data URL of that. So we can say await data 2 bytes. Await. Now, this is going to yell at me because I'm doing async inside a thing that's not async. Await's a reserved identifier. Yeah, okay, that's cool. Now, I might be able to fix this just by making this an async callback. Easy. Easy. There was a link to that page from someone saying not to use A to B and B to A. That makes sense. That makes sense. Same problem, maybe. We still have garbage instructions. It looks like they go off the rail at the same point. What is happening? I mean, so, okay, why is there a space? Are you allowed to have spaces in base 64? Is that, like why is there a space here? Let me... There shouldn't be a space. What are these spaces? Where do these come from? AA, blah, 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 90, XA. Do I have to URL encode it? Base 64. Is there... Spaces are silently skipped. So, but where are spaces coming from anyway? Like, how is there ever a space entering this string? There's no spaces in here. Is it too long? Is that the problem? Is there an upper limit? Because the whole data's here. It just has like... So if I work backwards, right? There's this IJ7A sequence. IJ7A, it's a plus. It's a plus. Because you can't have a plus in a URL, right? You've got to URL encode this. Is there an option for this? Filler, we're awesome. Thank you so much. Thank you so much. CSGO Week Brazil 22. Awesome. No, thank you. That really does mean a lot to hear. And thank you very much for the follow. I hope you're enjoying the show, even if this is even if this has been a real doozy of a stream. URL. I feel like this has to be a thing, right? Yeah, how to encode plus. Special meaning. It means white space. Yeah, okay, so it's literally just a different string. Literally just a different string. Linux. Is there a command for this? There must be like a Perl script or something that does this. I can just pipe through, right? Base 64 URL. Base enc. Ah, okay. Cool. That is way better. What a long journey to work out that was what I needed. Base 64 URL. There we go. I think that's all we need. I think that's all that's it. That's it. Well, it's good to know that the problem... I mean, it was a fun journey debugging it. It was good to know that the problem... oh, nope. Hello? What's going on? What failed? Network error when attempting to fetch resource. Huh. So, in conclusion, I'm going to go back to using the old method. Because then I don't need async. String contains invalid character. What invalid character does this string contain? To array buffer. Oh no, hold on. I do want this. I think I do want this. A nice data string. A nice data URL rather. It's Where is this? You are spot on. I think this was actually better. I want this bit of the thing. And then I want to actually read what it says when I get an error and not just panic and undo what was working before. Async. So the good news is it's decoding correctly, right? Data to bytes. Okay, so now let's go back here. What's the error? Data to bytes is not defined. Network error when attempting to fetch a resource. That's probably the least useful thing possible. What's going on? Network, I mean, how is this a network error, right? It's a freaking application. It's a base 64 string. Have I not encoded it correctly? Like, what does that even, what's the difference between this and base 64? It's got this plus in it, but like this plus is illegal. It's not, it's got these characters that you can't have in a URL, right? What does this mean? Error when attempting to fetch a resource. Base 64. Network error. Okay. This is someone doing an actual request, which isn't right. I like that it shows you the base 64 encoding of this. That's nice. Return base 64 from fetch. That's also not what I want. I don't know, this has been a really disappointing stream, right? Because I just keep hitting these weird problems that don't make any sense. Like, this looks fine. This looks good. Pending? Fulfilled? Huh? Huh? It worked that time. Was that just bad copy paste before? And then I just need to say await. Oh no. Well, it's not gonna work because when I await it, it's gonna. Okay. Okay, we're back. We're back. We're on. We're cooking. We're cooking. I don't know what happened. I don't know what went wrong, but we're cooking again. It still doesn't work, but that. Oh, but is that because I It's because I didn't actually copy this one. I didn't actually copy it. I don't know, something confusing happened then. Oh no, never mind. Never mind, we're back to the same error. Oh, it's driving me crazy. Because this just looks totally fine. It looks totally fine. What does this actually say? What does this actually say? Unicode problem. This is not a Unicode problem, but that's okay. Base 64, specific algorithm, blah, blah, blah. Following alphabet, common variant of base 64 URL safe, which replaces plus with dash, plus and slash with dash and this. Cool, that's what we're doing. That's what we're doing. Oh, data URLs have neither. Data URLs have neither, so they use base. So, but this is a problem, right? Because, so we're passing this in as a URL, but then we're trying to turn it into a data URL. So actually, I think I really do want the other function. I really do want the other function. In conclusion. Okay, this is really silly. It's been a bit of a flip-flop, but in conclusion, I want this function. String contains an invalid character. Okay, what's the invalid character though? Tell me what the character is. This is why you feel okay being a junior. Who are you gonna ask? Yeah, well, I mean, let me put it like this. The difference between a junior struggling with a problem and a senior struggling with a problem, like, a senior can still get stuck in a problem for a really long time for a really silly reason. I think my next job, I'm probably gonna be a senior. If I do another full-time dev job. So, like, I don't know, the process is the same, right? You have to step through what's going wrong, you have to read your errors carefully. the main guidance that I've gotten from more experienced programmers with things like this is they usually sit down and like read the error and maybe have some related reading or something that they can point you to. But yeah, you know, it's definitely good. Like when I was a junior, I would talk to people and they'd be like, well, you know, read this, have you thought about this, have you tried this? And I was like, wow, I'm never going to be able to do that. And then after a couple of years, you're like, you start helping other people like that, and you realize, you know, you've like learnt so much and grown so much. Does this have the same problem? Does A to B work on a URL encoded version or not? So what does A to B do? What does A to B have? Does this... But does this use the URL encoding or not? Data URLs commonly used. I'm so confused. I'm so confused about what this means. Do I need to find and replace? Like, string contains an invalid character. Why? What invalid character? Is it this? Okay, let's try something else. Let's try dash. Okay, so it's the dash character. It's the dash character. So I need to do a find and replace. I need to URL decode it, right? I need to URL decode this. Oh, and that, oh wait, yeah, why didn't I think of this before? Obviously. JavaScript, MDN, let's search on MDN. Of course these functions don't take the URL encoded version. Decode URI component. Decode URI. Except it's not encoded, right? It's... I just want to find and replace. I just want to do a find and replace. That's it. JavaScript. I want to replace every slash with a plus. Where's this page? Hold on. Yeah. Oh, okay. Hold on. Bobius with the links again. This is helping so much. Basic to encoded blah blah blah. Yeah. Okay. That's it. That's what we need. Cool. So we're gonna replace the characters, yeah. Man, that was a really subtle and complicated journey. Except I want to do this, yeah, dash with plus and... Why does it still yell at me? var, rare use of var. It should replace it, right? Anyway, let's copy the big one and see what happens. This will still break, right? It's still gonna have the same issue. No? Okay, third time's the charm. Oh my gosh. Oh my gosh, I think this is it. Is this still too many instructions? No. Because it might still be too many instructions. Let's have a look. Let's have a look. Thank you, Bobius. I think you might have saved the day yet again. MC, blah, 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 either or null. Load words C, 0, C. This looks okay. So what if I reset here? What if I start stepping through? 0 instruction. So it looks like this still isn't loaded into memory, which is weird. I don't know what that's about. Write program. And this is part of the WASM. Load from vec. So we should be able to do this, right? We should be able to do this. VM memory, load from vec. Add offset. You're almost shocked that seems to have worked. That was literally it. It was replacing the invalid characters. That's all it couldn't understand. That's all it couldn't understand. I think my brain's been fried by this. I can't see what's going on. I can't see why it's init VM, program run, program start. What am I trying to copy? Assemble and upload. And assemble and upload, all that does is all this stuff, and then it makes a uint8 array and it calls write program. So why doesn't it work when I try and do that? Why doesn't it work when I do that? Update. Does update code view do something funky? There's a lot of intertwined state here that's a bit gross. This is the other thing, like, yeah, that reactivity's helped me manage some of these weird overlapping states. No. Okay. Update code view, disassemble. Write program. Program bytes. Program bytes is the buffer uint8 array. Oh, but we want an offset of this. So we want it to be like a substring of this. So we want we want to take like some subslice of this. Subarray, dot subarray. From the offset. This is silly, but it'll work. Cool. Okay, now we're cooking. Now we're cooking. No, we're executing different instructions. Are we? No. Shift left, BP, P, jump. Yeah? Oh yeah? Nope. Okay. We're jumping to the wrong spot. We're jumping to the wrong spot. We're jumping to this weird other, what? Our label resolution has gone funny. Okay, but we're loading this in. We're loading this in. That was a long side quest to just look at this, but again, you know, this is all gonna help. And then once we tell it this binary is actually a full blob with a header and everything, that's gonna be better. So that's tomorrow. I feel like we didn't achieve much this stream, and also I did achieve much. We didn't do this. What did we do? We cleaned up a lot of stuff internally, and we played with actually loading data better. This is going to be useful. This is going to pay dividends really soon once we start actually outputting code. It's just taken a while to get there. We'll see how we go. We had a fun journey. It's about the friends you make along the way. But my brain is definitely fried by spending that long looking at weird JavaScript errors. Not really much of a mood, but that's okay. Let's find someone fun to raid. Let's throw the love on and do a really good raid. If anyone has any good channels to recommend, always happy to take a raid recommendation. Maybe someone who's just come online, someone, I mean, if they're Australian, that's even better. If they're doing Rust, that's even better. If they're doing compiler stuff, that's even better. Thank you, Bobbius, for your help. It really does mean a lot. Composite, the game, music and art. Let's looking for something codey. Looking for something very codey. Minigame. Has that person been up for 6 hours? Maybe won't raid them. They're ready for bed. Game. Twitch-based MMO. Vue 3 plus Python. It's kind of relevant to some stuff I've been doing lately. Game dev, third-person action combat. Who's a good... Bobius is ready for bed soon. Yeah, no, definitely. Gotta look after yourself. Puzzle game in Godot. Something interesting, but it's in German. What is this? Okay, this looks weird. Let's raid this person. Web dev, Tree.js, Benjamin Bors. So let's throw some viewers over there. Thank you everyone who's been tuning in. It's been a lovely stream. We've got some stuff done, even if I'm a bit disheartened by not getting as much done as I hoped. Thank you so much for everyone who's been hanging out. It's been a good time. I'm Tom, and I will catch you next time.